Hello everyone, Assalamu alaikum. Welcome to the chapter 8 Random Variables. There are two subtopics, which is the first one is the discrete random variable, and then the 8.2 will be the continuous random variable. Let's learn some of the learning objective of the discrete random variable. The first learning objective is to construct probability distribution table and probability distribution function. The second learning objective will be finding the cumulative distribution function. And then the third learning objective is finding the probabilities from the PDF and the CDF. And then the last objective will be finding the expectation and variance of the discrete random variable. Let's have a look at this example one, a fair die. So basically there is only one die, so we call it there is only one die is rolled. Okay, if X represents the number on the die, there is only one die, do you remember? Show that X is a discrete random variable. So first thing first is we gotta name it first. We name that the random variable X is the number on the die. So we write here the number on the die. And we also know what are the numbers, which is 1, 2, 3, 4, 5, and 6. So make sure you do the step 1 here so that you know what is your topic all about. What is this question all about, which is the number on the die, which is number 1 until 6. And so we can sub in the number 1 until 6 in the table. 1, 2, 3, 4, 5, and 6. Okay, and then we gotta find the probability of each of this number, which is probability of X is equals to 1. What is the probability of getting the number 1 when you roll the die? When you balingkan satu dadu itu, apakah probability untuk mendapat satu? What is the probability? You already know it. You already learned from the last chapter, which is chapter 8, chapter 7, probability. And so the probability of getting 1 is 1 out of 6 chances, isn't it? So whatever the number that you will get, it is just 1 out of 6 chances. And so you can write down here 1 out of 6 chances for every numbers. Because when you roll the die, you do not know what you will get, but at least we do know what's the probability. And so we are happy. Okay, remember this is the second step. The table will help you a lot. Okay, and then the last step is just we list down the summation. This is a very important thing. We list down the summation of the probability. So you remember to put this sigma to represent the summation. And then here we go, we will write down each of this. X is equals to 1, and then probability of X is equals to 2, and then probability of X is equals to 3, and then probability of X is equals to 4, and then probability of X is equals to 5, and then probability of X is equals to 6. So you write each of them to represent the summation of it, and then you write down its probability, which is, you know it, 1 over 6 chances for every 6 of this. So then you total them together, you will get 1 eventually. So the total probability is equals to 1. And that is our goal. Okay, this is our goal. When we get the goal, when we get the summation of the probability is equals to 1, we are so happy. Okay, when we are happy, we can do the conclusion. Since, I think the word since is very common now. The since, so now since the summation of the probability x is equals to 1, then, or therefore, x is x is a discrete random variable. That is what we want, because the total probability is always equals to 1. Therefore, x is the discrete random variable. Discrete means it can be countable. It is countable. Okay? That's why it is logic to us. Let's go to the example 2. 3 fair coins. So there are 3 coins basically. The word fair meaning you will get a 50% chances of getting head or tail. That is just the meaning of fair. Fair is just 50-50 chances, okay? So there are 3 coins lah. Just focus at that word. 3 coins are tossed. Dibaling 3 coins serentak. X represents the number of tails obtained. Show that x is a discrete random variable. So now we are doing the same thing all over again like we did in example 1, which is let x is equals to the number of tails obtained. Okay, you give it a name first so that you know what you got to do for the next step. Okay, again, I put it as the step 1, and then the step 2 is where sometimes you can do a tree diagram, sometimes you can do a table instead. But this one, I just want to know how many outcomes that will happen when you toss the coin, you know. So this is not the first toss, second toss, or third toss. This is actually first coin, and we have the second coin and third coin, because the question said here there are 3 coins. So that's why I must put here the first coin, the second coin, and the third coin. And so I make a tree diagram. So a tree diagram will just help me to find the outcomes. So when I do the tree diagram, I have found out that 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes that will happen. And then I just need to find how many number of tails obtained when we toss the 3 coins. And so first outcome we have head, which means there are no tails. There are no tail. And then the second outcome is where we have head, tail. Oh, there are 1 tail then. And then the third outcome is head, tail, head. So there are also 1 tail. And then head, tail, tail. Oh wow, there are 2 tails now. And then tail, head, 1 tail again. Tail, head, tail, 2 tails. Tail, head, 2 tails again. And the last outcome is tail, which is 3 tails now. So, just a moment. So there are 3 tails here. So that's it. There are no tails, meaning 0 tails. And then we have 1 tail, 2 tails, and 3 tails. Therefore, we can write down here our random variable x has 0 tail, 1 tail, 2 tails, and 3 tails. And so we can make the table as our next step, step 3. And then we can put the numbers inside of this table after we have sure that what are the topic all about. That's why it is important to make sure you know what are the numbers. If not, you will do it wrongly. Okay, so then we find the probability. What is the probability of getting 0 tail? Okay, 0 tail is just 1 out of how many outcomes then? The total outcomes is 8. Therefore, these 8 possible outcomes is helping you that there is 1 out of 8 chances of getting probability where there is 0 tail. Okay, so simple. And then you gotta count for the next one how many tail no, what is the probability of getting one tail? So how many outcomes do we have? So there is one, two, three. There are three outcomes out of eight possible outcomes. Therefore, the answer is three out of eight chances, three out of eight chances on getting one tail, and then two tail. Slowly, there are two tails here. So one outcome, two outcomes, and then three outcomes again. So three outcomes as well. Three out of eight chances of getting two tails only. And then the last part, which is three tails. So three tails is only one outcome. Therefore, we know it is one out of eight chances. So yeah. So you total them together. Ask yourself whether you get a 1, the total probability. If you get 1, when you total them together, 1 plus 3 plus 3 plus 1, do you get 8 over 8 is equals to 1? If you get it, yes, you are so okay right now. So you just put a conclusion saying that since the total probability of x is equals to x is equals to 1 out of 8 plus 3 out of 8 plus 3 out of 8. Yeah, you can just directly write down its probability plus with 1 over 8. And then you plus them together, and yes, you get 1 total probability. So, or therefore, the random variable x is a discrete random variable. That's it. You have shown it. You can put the word shown there. That is how you show PDF. Okay, that is how you show the total probability is equals to 1 when they ask you show that x is a discrete random variable. Okay, next question is construct probability distribution table, which we already have done it. Yeah, we done it already. We just used the table that we have here and then write down the probability distribution function. So remember, this is just PDF. The short form is PDF of discrete because we are talking about discrete random variable. That's why I put PDF of discrete random variable. In 8.2, you will have PDF as well, but we call it PDF of discrete. No, not discrete anymore. In 8.2, we call it PDF of continuous. PDF of continuous random variable instead. Yeah, that will be in the next video lah. So question B is where we gotta find the PDF. So function is where we need to refer the notes here. This is how we write down our PDF. We need to write down our answer in piecewise function. I will teach you how do we write them. Okay, so it is just in terms of piecewise and it's very easy. All you're gonna know is that we must write down our px is equals to x first. Okay, so, and then we put this big curly bracket, okay, to represent the how many probability that we have here. So this is our probability. So make sure you write down the same thing. Okay, you don't change it. Yeah. In chapter 8, we always write this way: px is equals to x. We always write this kind. Okay, and then we put a curly bracket here, and then we're gonna find its probability. What do we have here? 1 over 8, and also 3 over 8. There are no other numbers than just these two numbers, and so we write from small to big. So 1 over 8 and also 3 over 8. There are only two similar probability, and so what are the numbers of x? The number of x is just for probability number 1 out of 8 is just 0 and 3. So you can put down there 0 and 3. But when the probability is 3 out of 8, the x is just 1 and 2 according to this table. So that's why this table is very, very helpful for whatever the question is asking from you, whether it's PDF of the discrete. So basically, this is the way of writing down your answer when they ask you the PDF. of discrete random variable. Okay, remember this. Always remember to write in piecewise function. For this particular question, write down the probability of distribution function. They want the piecewise. Write it down so that you always remember they want the piecewise function. Okay, we're done here and here. Let's last part here, which is sketching the graph of the probability distribution function. So the last part will be sketch the graph of the PDF here. So I always love to write down this full name here, PDF graph. And then the graph consists of boxy x, the x-axis, and the boxy of the probability. Okay, px is equals to x. The thing is, what is the value of x? Again, you question yourself. So you already know what is your x, which is from 0, because 0 tail, isn't it? Which is 1, 2, and 3. And we also know that there is a probability called, there is the number of probability which is starting from 1 out of 8 and also 3 out of 8. There are two numbers of probability. That's why my graph is very short here. Okay, there are only two probability. That's why my graph is quite short there. But that is not the main point. The main point is how we draw it. How do we draw the PDF graph? The PDF graph, I repeat. So PDF graph is just drawing a vertical line. Okay, a vertical line. So we know that the probability of getting a 0 tail is 1 over 8. We know it. So I'm going to put this a very thick line here, thick vertical line here, to show you that this is the line, the vertical line. And so the probability of getting 1 number of tail is just 3 out of 8. Right? Okay. And then the probability of getting 2 tails is also 3 out of 8. And then the probability of getting 3 tails is just 1 out of 8. Therefore, this is the graph of the PDF, where the topic about is the number of tails. Therefore, it is not that hard. Just remember that the graph of PDF is always vertical. And that's it for the PDF. Thank you.